It's no secret. The world is ending.
Oh my God! Okay, it's happening! Everybody stay calm!
Okay, that's not entirely true. But global concerns of rising temperatures are slowly growing. The effects of greenhouse gas emissions are causing panic everywhere, from rising sea levels to bizarre weather patterns to disappearing ecosystems. According to the Government of Canada, the country's greenhouse gas emissions for 2021 was 670 megatons, which was a 1.8% increase from 2020. Electricity is the sixth leading cause of greenhouse gas emissions in Canada, making up 7.7% of total emissions in 2021, which was 52 megatons of CO2 equivalent. 28.2% of Canada's emissions come from oil and gas, emitting 189 megatons of CO2 equivalent in 2021. Reducing Canada's gas emissions will mean becoming less reliant on using oil and gas and implementing more use of electricity from renewable energy sources. Much of Canada's energy comes from hydroelectricity, which uses kinetic energy of rivers and converts it into electricity. This form of energy provides Canada with 59.3% of its electricity. But even though much of our electric needs comes from hydroelectricity, there is a largely untapped resource with the potential to generate huge amounts of energy. And it's all around us, literally. Covering 71% of the Earth's surface, oceans are an enormous source of energy. Marine renewable energy will play a large role in Canada's efforts to reduce greenhouse gas emissions and increase clean energy sources because of marine energy's abundance, diversity, and reliability. Marine energy comes from the potential and kinetic energy from waves, tides, and river currents. This energy can be converted into electricity through several different methods. According to Marine Renewables Canada, the total estimated capacity of marine energy in Canada, including tidal, wave, and river current energy, is 340 gigawatts, 5 times the energy consumption of all Canadian homes. That's a lot. First, let's look at tidal energy and its presence in Canada. Tidal energy is generated from the rising and falling of tides due to gravitational pull of the sun and moon. The kinetic energy comes from moving water in natural flow of tidal currents and the ebbs and tides moving in and out. The closer the moon is to the Earth's surface, the stronger gravitational pull the moon will have on tides, and this is expressed in the relationship where the force of gravity is inversely proportional to the radius between two masses. There are two forms of tidal energy: tidal current energy and tidal range. Canada is currently working on extracting tidal current energy. This form of energy is able to generate electricity by powering turbines. This is comparable to a wind turbine that's instead in the ocean and is able to generate electricity from a steady, predictable source. Canada's coasts have an identified 190 tidal power sites that generate in total an estimated capacity of 42,000 megawatts, which is the total mean annual wave power. This is greater than 63% of Canada's total consumption per year, enough energy to displace over 130 million tons of CO2 emissions. While not all kinetic energy is able to be converted to electricity, it is possible to convert 80% of kinetic tidal energy to electricity, versus 20 to 40% of wind and 40 to 50% of solar energy. Tidal energy also takes up less space than wind or solar farms. The largest tidal plant spans 12.7 kilometers, located in South Korea, while the largest wind farm in Alberta spans 202 square kilometers. The mechanisms are also easy to install and remove if needed. Next, let's examine wave energy and its uses in Canada. Waves are caused by the friction of wind against the ocean's surface, creating wave crests and transmitting kinetic energy along the water. Like tidal energy, wave energy is able to power turbines to generate electricity. The energy propagated by a wave is proportional to the amplitude of the wave. Wave energy is typically harnessed using chambers. When water levels rise, air is forced out of the chamber, and this air pushes a turbine. There are several mechanisms that carry out this function, such as attenuators, oscillating water columns, and point absorbers. The Atlantic and Pacific coasts of Canada are abundant in wave energy. The Pacific coast has about 37,000 megawatts of energy available, 55% of Canada's yearly energy consumption. The Atlantic coast has a potential energy capacity of 146,500 megawatts, which is over double the country's yearly energy needs.
You know I had to double it.
Clearly, Canada has a resource with a lot of potential that is not yet widely implemented. There are many clear benefits that marine energy has alongside with being a zero-emission energy source. Marine energy is reliable and predictable. Tidal energy is predictable by years ahead, and wave energy is twice as predictable as wind and solar energy. Implementing marine energy also creates more diversity in energy sources. Not having to rely solely on one energy source stabilizes supply and pricing. Marine energy also creates opportunity for rural and remote areas. Many Canadian remote communities, including Indigenous reserves, have their own fossil fuel plants. Marine energy would be able to provide remote areas with clean, cost-effective energy that creates new job opportunities. Along with more jobs, marine energy has the potential to create economic growth. According to Marine Renewables Canada, with an estimated global market potential of $900 billion, Canada's supply chain could capture $45 billion by 2050 with even a 5% market share. There are reasons, however, as to why marine energy has not become more widely implemented. While new job opportunities can be created, many include dangerous working conditions in ocean environments with heavy-duty equipment in high currents, darkness, and harsh weather. Many areas with high marine energy potential are remote. However, infrastructure in areas where marine energy plants are located is needed and would have to be built. Additionally, marine energy includes large development and installation costs. According to energyrates.ca, tidal energy is an estimated 66 cents per kilowatts an hour, compared to wind energy costing 20 to 30 cents per kilowatts an hour. Lastly, there has also not been enough time or research to understand the environmental impacts of harvesting marine energy, including the effects on sea level and water quality and marine life. Sustainable Marine Energy Canada, a tidal energy company, had functioning turbines in the Bay of Fundy in Nova Scotia, generating power to the Nova Scotia grid before removing their turbine platforms in 2023 after 5 years and $60 million. The company claims they were forced to end their project due to bureaucratic barriers made by the Federal Department of Fisheries and Oceans, who claimed that the turbines were likely to harm aquatic life. Whether or not the claim made by the DFO is true, government support is essential in implementing marine energy sources. Creating a greener, sustainable way of life is absolutely essential if we want to slow the effects of climate change, and this begins with governments and corporations implementing policies and allocating money that work towards a sustainable future. For example, the French government is planning to use at least 65 million euros towards Flowbot, a tidal energy pilot farm expected to be in use by 2026 that will provide energy needs to about 20,000 people for 20 years. The future must include using renewable, net zero energy sources, such as marine energy. That is why energy sources like marine energy are going to play a large role in Canada reducing greenhouse gas emissions and creating a better planet for us now and in the future. Thanks for listening. I hope you learned something and are inspired to save our planet. Toodles!